Welcome everybody. Thanks for coming tonight for a presentation of regular expressions, friend or foe. Why not both? Actually, most people that have used regular expressions kind of feel this way. Sometimes they feel like they're a friend, sometimes they feel like they're a foe. Depends on how well it's working for you. So hopefully though, by the end of this presentation, it'll be more of a friend and less of a foe. So, regular expression, I basically stole this definition right off of Wikipedia. So it's basically sequence of characters that forms a search pattern. One description I saw that was fairly good is think of it like wildcards on steroids. So if you've ever used command line wildcards, star, whatever, it's the same idea, it's just you can do a whole lot more with it. They aren't random jumbles of punctuation, even though they look that way. They're carefully thought out jumbles of punctuation. Basically, regular expression is kind of hard to say, so people will abbreviate either regex or regex or regex, depending on how you want to pronounce it. I'm going to pronounce it as regex just because that's easier to say, and I'm lazy. So, just so you know, when I say regex, I'm talking about regular expressions. This ended up being a lot longer in putting together, and I had to end up tearing out a whole bunch of content because I didn't want you all to be here all night. So I'm not covering a few things like Unicode. In fact, I probably won't cover that in the next talk because that's a whole talk in and of itself, just talking about Unicode. I'm not going to show you all of the character set abbreviations or the escapes in sequences or the modifiers. I'm just going to cover the most common ones that you'll see. The rest you can look up. Some of the other ones I'll have in part 2 of this talk when I give that. So, metacharacters. These are basically characters that have special meaning in a regular expression. So they're not taken literally as whatever the character is that they are. They have some sort of special syntactic meaning. Backslash is quoting the next metacharacter, including itself. So if you want a literal backslash in a regular expression, you have to put 2 of them in there. You may have seen this concept in other things. Backslashes tend to be a pretty common escape character. So the caret matches the beginning of the line of a string. The period matches any character except new line, except for the exception. There is a flag that will change it so that the period will match a new line. We'll talk about that later. $sign matches the end of the line, or before the new line at the end. Sometimes you care about that distinction, sometimes you don't. I put it in there, but a lot of times you don't. The distinction doesn't really matter that much. Okay, parentheses are for grouping and capturing. For some reason the documentation just mentioned grouping, but actually capturing is a very important part of that. So I added that in there. And we'll talk more about that later. Square brackets give you bracketed character classes, and the braces give you repetition. Any question on any of those things so far? I know at this point it's just like information dump. I'm just going to give you a bunch of characters, but then hopefully towards the end we're going to start to put it together into something that's a little more coherent. Okay, so the easiest regular expressions you can match are just matching literal characters. So if we have a string, hello world, and then over here we have a regular expression that's just the word world, these are all taken as literal characters, so capital W, lowercase, everything else. and the part that's highlighted in green, that's exactly what will get matched out of there. And so this pattern will match, and this is the part that it matched. Escaped metacharacters are treated as literal characters. That's what I was referring to before. If you want them to be treated as literals, you put a backslash in front of them, that takes away their special meaning, and it says, I really do mean a square bracket. I don't mean a character set. I actually want a square bracket. So if you had a string like this, notice I've got the backslashes in front of that, and so that will match. Any questions on that so far?
Without the backslashes too, we still match.
That's a very good point. Actually,
Saying
you're absolutely right. Yes, they would match for the same reasons, but it still would match. Good.
Explain the equals tilde.
Oh, okay, the equals tilde is the binding operator. And so basically it just takes whatever string or scalar variable or whatever you've got on this side, and it matches this pattern against it. Most of the time, the default characters you use are the forward slashes. There are actually other characters you may see used because you can get what is called leaning toothpick syndrome. Like for instance, if you're trying to match a Unix path, well, forward slash means something, right? So every single one of those forward slashes you have to put a backslash in front of. So you end up with a bunch of things that look like leaning toothpicks.
But that's not the same thing as like a plus equals. It's not hello world, it's hello world tilde.
No. All this does is it's saying take whatever's here and match this pattern against it. And then this returns, most of the time you'll have this like in an if statement, or you'll have it in a situation where you're capturing information out of it and doing something with it. So these are basic but mostly useless, as far as you would most likely never just write this on a line by itself. It would be in an if statement, or it would be in a loop, or somewhere that you're doing something with the information that you're matching. Does that make more sense? In this case, I was just trying to keep it simple, just talking about just what matches. We'll get into a little bit more examples of how you actually use it. So, is that good for now? All right. Anybody else? All right. Okay, now we'll talk about character sets. You remember the square brackets are what give you character sets. So I think probably, well, first we'll look at the one, this sentence contains vowels, A, E, I, O, U. This means if any of these characters in this set are contained over here, then it will match. And actually I should have put the green background on the vowels that would match. Basically, since there are vowels in here, if this were all consonants, it wouldn't match. Since it's got vowels in it, it will match. And the order doesn't matter. I could have put these all in a jumbled order. Doesn't matter. It's just a character set, and it's just saying if any of these things are in here and match, then it will match. That's what he was referring to in the other one where I had world, where if I left the backslashes out of here, it still would have matched, but for a completely different reason, because then this would have been a character set with a capital W, and I could have jumbled these all up, and it still would have matched that. Does that make sense? Character set just means, here's a set of characters, and I want these things to match something in the string. Okay, so if we want to make a pattern that matches like an HTML color, we've got a number sign, which this we don't have to backslash because it doesn't have any particular meaning. And then we've got a character set. Now you notice what's different here is we've actually, you can specify ranges as a shortcut. So we've got 0 through 9, A through F. In this case, if these were capital C's, this would not match because I didn't put capital letters in here. If I wanted to, I could have put capital A through capital F, and then it would have matched lowercase and uppercase. There's also flag that you can add that tells it to ignore case. That'll work as well. But in this case, I'm just trying to keep it simple. This will match any number 0 through 9, any letter A through F. We don't want to go any further than F because that's as far as hex goes, right? You go 0 through F. And then each character set is for each digit or hex digit, I'll say. So basically we've got 6 here, we've got 6 here. And then this right here is just a Perl comment on the end saying matches HTML comment. So far so good. This is actually not a great way to do this. I'm going to show you a much better way to do it later. But at this point, I'm starting basic. I'm trying not to pull any tricks. And then I'm going to show you the tricks later to make things a little better. Then you can also invert character sets. If you put the caret at the beginning, it has to be the first character inside of that character set. It means match anything that's not in this character set. That's why in this case it matches ID, because 007 falls within this character set. So you can basically, if it's easier to try to match what is not in the character set, then you can do it just invert the character set. It really depends on what you're trying to do, which is easier. Whether it's easier to specify what you don't want or easier to specify what you do want. As I'm sure you've found in other life experiences, sometimes it's just easier to do it one way or the other. So far so good? Right. Okay, now we're going to just get back into some more definitions here. These are character set abbreviations. They're basically, you've got character sets that are used so commonly that they decided it was worth making it into its own special short little characters so that you don't have to, keep specifying this long character set. So this \lowercase w matches a word character. I put quotes around word because basically it's Perl's definition of a word, which is alphanumeric plus underscore. So you noticed before how I mentioned if you wanted uppercase and lowercase, I could specify those separately. So it's A through Z, capital, A through Z lower, 0 through 9, plus underscore. That's what this is, the same thing as this. You can literally replace them for each other in a regular expression. It'll do the exact same thing. This right here is just a shortcut. That makes sense so far? You're going to see a pattern here too. Capital W is the inverted set. Matches a non-word character. So anything like white space or any punctuation that's not an underscore, stuff like that. That's the kind of stuff that'll match if you're looking for things that are not a word. Lowercase s matches a white space character, which there are several that are defined. This is an actual space here. This is a form fee. This is a new line. This is a carriage return, and this is a tag. All of those are considered, either horizontal or vertical white space, and \s will match any of those. So if you only want to match a tag, you would just put a \t in. Or if you only wanted to match a space, you just put a space in. But if you don't really care what the white space is, you just say, I want to match if there's white space here, then that's when you use the \s. \uppercase s, as you might have guessed here, this is the pattern. Lowercase matches the set you want, the uppercase matches does the inverse of that. So this will match any non-white space character. So this will actually go beyond what this up here will by quite a bit, because it'll match any punctuation, any numbers, any letters, anything that's not white space, basically, it will match. So, \D, this one actually gets used a lot, or I find that I use it a lot. Match a digit character 0 through 9. If you're matching like phone numbers, or social security numbers, or ID numbers, or database IDs, you end up using this a lot. There are a lot of, let's face it, in programming, we use numbers a lot. So this tends to be pretty useful. And then the \D matches, and I didn't do this, I did a cut and paste error here. Matches a non-digit character. I need to fix that now. It's not white space, a non-digit character. So anything that's not 0 through 9. So punctuation, letters, things like that. I apologize. That was a cut and paste error. All right. I just wanted to put these in here for the sake of completion. I more or less explained them on the other slide. Let me know now if you have any questions about what they are. But these are basically, that's a tab, new line, return, line feed. The time that you'll care about new line versus return is when you're dealing with either Unix line endings or Windows line endings. Those are actually two different things. In Unix, it's just \n. In Windows, correct me if I'm wrong, it's been so long since I've done this, I think it's \r\n. They actually use two characters to indicate the end of the line. That's why if you've ever taken a Windows file and put it on Unix, you'll end up with like ~m. A lot of times you'll end up with weird characters at the end of the line. That's why. It's because it's trying to interpret this this combination of characters, and it doesn't treat them the same way as Windows does. So, anyways, I've never had to worry about a line feed. I don't know if anybody else has, but I just put it in there because it's one of the white space characters. That's mostly for printers. Okay. So far we've been talking about things that match characters, right? Either numbers or letters or punctuation or something, actual characters. Now we're going to talk about things called anchors. These don't match characters, they match positions in the string. Okay, very important distinction. So you can almost think of them as matching in between characters. So you've got, the places where the characters are, and then you've got the spaces in between them. So a caret will match the beginning of the string. So that's literally the space, even though no space exists, but you can think of it the gap at the very beginning of the string. That's where that matches. The $ matches the end of the string, which is, basically the gap that comes right after it. I don't want to say space because there's no actual character there. It's just that spot that's at the end of the string. And \B matches between a word and a non-word character. And you remember the definition of a word character was A through Z, capital, lowercase, 0 through 9, and underscore. So a transition would, let's say, you say the cat in the hat. Every time you go the and then space, in between the E and the space, \B would match. And then it would also match after the space and before the C in cat. Anywhere you've got a transition from a word to a non-word or a non-word to a word, either way, it'll match. So that's why I want to make the distinction. It's not matching characters, it's matching actual positions in the string. So far, so good. Everybody down with that? Okay. Oh, and I should probably point out, most of the time, the reason you want to use anchors is to be a little more specific in your regular expression. If you, like for instance, if you're validating, a field user input, a lot of times you'll want to use both of these because that says, I really want to match everything the user entered, not just one part of it. I don't want to just see if one part of it is a certain pattern. I want to start at the beginning, I want to end at the end, and I want to make sure everything in the middle matches. Like for instance, if they were entering their account ID number, and it's all numeric, and it was 10 digits or something, you would just want to make sure you would want to start at the beginning, start at the end, and make sure there are 10 digits in the middle, nothing else. And that's mostly what you use anchors for, is when you want to be very specific about, that this whole thing matches, or this very specific part matches. That makes sense? Okay. These are the modifiers, or sometimes called flags. I had alluded to this one earlier. You remember the regular expression starts with a / and ends with a /. You put the flags at the end after the closing /. And if you put an I there, it will ignore capitalization. So if you've got, like in my earlier capital world, capital H, hello, capital W, world. If I put an I at the end and then matched with a lowercase w or a lowercase h, it would match just fine. Because I'm telling it, I don't care about case, just match to the letter. So that one is, as you can imagine, is pretty common. It's used a lot. \x, which I might get into that one more in the next talk. Really didn't have too much time to talk about it here. What this does is it gives you an extended regular expression, so it will ignore most of the white space in the pattern and allow you to put comments inside of it. What it does is it allows you to take a regular expression that might be this long and then break it out into several lines and then put comments around each part so that it's much easier for someone to understand what it's doing. And that's what that does. It's just a tool to make your regular expressions easier to understand. And that's why it ignores white spaces and comments, is because obviously if you're putting it on multiple lines, we already learned multiple lines are white space, right? And then the # is the Perl comment character. So it'll ignore everything to the end of the line after a comment. So that way you can, you can comment every single line in there and tell exactly what every part of that regular expression is doing. Like I said, I'll hit that more in the next talk. Just didn't have enough time for it here. This one is another one that gets used a lot. G is global. That means you want to know every single time that matches. Like if you've got a paragraph of text and you want to pull out every number in there, you would use G and you use the \E, the digit, and it would go through and find every single digit that's in that paragraph. Or if you wanted to do a word count, you could just look for everything that's not white space and count it as a word, or come up with a little more rigorous definition of what a word means to you, and use the G. It'll find every single one, and then you just count them up at the end, and then you know exactly how many words you've got in that paragraph, or page, or whatever it is. The /S, this is the one I alluded to earlier. It will treat a string as a single line and let period match new line. So that means even if your string has embedded new lines in it, it will treat that as if the whole thing was on one line. And it will allow the dot or period to actually match new lines. And that comes in handy Again, I'm not going to talk about that one too much this time, but some of the more advanced examples that I want to give is really handy to use this block. Any questions on any of these? Right, I apologize for this line getting cut off, of course. Aspect ratios and everything being different, and the CSS never comes out perfect. Looks great on my screen, I bring it in here and stuff gets cut off. What are you gonna do? Anyway, repetition. So far we've just been talking about things that match like single characters, right? Like remember for the HTML color, you've got 6 hex digits, so we needed 6 character classes to do that. Well, that's not very efficient, right? You've got 6 of the same thing listed over and over. So now we're going to talk about how do you fix that. You use these characters. You've got these special meta characters. Question mark matches whatever's ahead of it 0 or 1 time. And I'm going to point this out now, and I'm going to point this out again later. 0 is tricky. It may not seem tricky, but it's tricky. It will, I guarantee you, it will mess you up when you're trying to do a regular expression. It seems innocent enough, 0 or 1, but I tell you what, when it matches 0 times, a lot of times it will throw you off. Okay, plus, match the previous 1 or more times. Star or asterisk, match the previous 0 or more times. And this is the one that probably is the #1 culprit for getting you into trouble with regular expressions. Is this will a lot of times do things that surprises you, but if you remember the definition, it really shouldn't surprise you. I'll show some examples later. All right, if you remember earlier when I was talking about meta characters with the braces, I said that it helps you express repetition. What it does is it matches exactly n times. So you put a number in here. If I put, for example, a 6, remember we had 6 hex digits, I could have had just one group of one character set with the 0 through 9, A through F, and then put in braces 6 after. And that would have matched the whole thing. Made it much shorter, much easier to understand. I've actually got an example, so I'm kind of stealing my own thunder, but we'll get to that. And, comma and, matches at least n times, but not more than m times. So that's if you've got, you know, some range that you want to match. You just specify, you know, I want at least this, but no more than that. I don't tend to use this a whole lot, but it comes in handy occasionally. And then n with just a comma, nothing after it, matches the previous n or more times. So it's kind of similar to the plus, where n is 1. But in this case, you can start n to be 10. So you can say 10 or more. So it will match at least 10 times, but it will also match 11, 12, 20, 100, 1,000 times. All right? Does that make sense to everybody so far? All right. This is the one where I was telling you I was giving it away before I got to it. You notice that's what I did. I replaced that whole long thing and I just put a 6 after. It just means match this character set 6 times. We've got 6 hex digits in the color, and we've got our number sign up front, and so this matches exactly like the other one did. Just it's a heck of a lot less to type, a lot less error prone since you've only got one of them to screw up rather than 6 of them, and hopefully a little easier to read once you get used to reading regular expressions. And that's mostly what throws people off is they just look at something like this and they go, oh my gosh, what the heck is that? Well, the thing is, you have to, it's just like learning to read. You don't learn to read a paragraph at a time. You learn to first what the sounds of the letters are, and then you learn how to put those together into words, and then you can read the paragraph. regular expressions are just like that. And I think that's what throws a lot of people off in learning, is they just look at something like this and they go, I have no idea what that means. I give up. So what I'm trying to do is walk you through step by step and teach you the letters and the words first, and then we'll get to the paragraphs. So hopefully it'll make more sense. Either that or my theory is just completely wacky. That's up to you guys to determine at the end of this session. Okay, so I put another example in here. Let's say you wanted to match US currency. You remember $ has the special meaning end of string, so I have to put a backslash in front of it. Backslash B means digit character. I put a plus, that means 1 or more, right? So that means I could add as many digits here as I want, as long as I at least have 1. So if I wanted to specify this only a cents, let's say it was just 59 cents, I'd have to put a 0 there, otherwise it wouldn't match correctly. And this may not be how you decide you want to match currency. You may want to be more flexible. This is just the example I chose. So then it's followed by a literal period or decimal place, so I have to backslash that. Then it's followed by 2 digits. So I'm just deciding, we only want 2 digits, that's it. If you were, instead of doing currency, you were doing some sort of scientific or mathematic calculations, you probably wouldn't want to reduce it just to 2 digits. You would want to allow a lot more precision. So does this make sense when I walk you through it step by step, each little piece? That's basically how you have to read a regular expression. You don't read it all at once. Just look at each little piece and figure out what that piece does, and then go on through. Everybody good with that so far? Nobody's had it explode yet? Okay, good. All right. This one here, I'm kind of alluding to. You're going to see constructs like this a lot in my next presentation for this. So I kind of use it as an example. What we've got, you remember, this is a character set character, so we have to backslash it. Then we've got 2 dashes. Those don't have any special meaning, so we don't have to backslash those. Then we've got a backslash S, which you remember is white space. So, but then you notice we've got the star afterwards. And star means 0 or more. In this case, I've got no white space there. So guess what this does? This actually matches, because this is 0 white space, and this is 0 or more white space. So that matches. That's the thing I was telling you that will catch you off guard. It still does it to me all the time too, even though I know this. I will still occasionally put the star in there and they go, what the heck is this thing doing? And it's like, oh yeah, it's matching nothing, right? Because that's one of the things that it's allowed to match. Okay, over here, or in the middle, I've got a capturing group of parentheses. You remember I said this was for grouping and capturing. What capturing means is it puts it into a special variable because you're interested in that piece of data that you're matching against. This is where I was answering your question earlier. This is a more realistic example of something you can do. I want to not only match against the string, but I want to extract information out of that string. Well, this is how you do it, is with parentheses. Basically, it puts it into, in Perl, there's a couple of different ways of doing it. Other languages maybe differently. But basically, in Perl, it's $1 for this first set of parentheses, $2 for the second set. You can also use, within the regular expression, \1, \2, \3. You'll sometimes see that, so just know there's a couple of different ways to express that. And it's just counting the parentheses. So the first set of parentheses is is always 1. The second set's always 2. So after I ran this line, I can have a line here that says print $1, and it's going to print tag with a couple of spaces after it. You'll have to take my word for it that there were 2 spaces there. Of course, being in HTML, I can pass this on the wall. We should have put a print tag on it or something. Anyway, so you'll notice one other thing that I haven't talked about yet. This extra question mark here, what this does, we'll get into this more, a little better explanation later, is this kind of puts the brakes on the dot star. Dot star means match any character except new line, right? So I'm looking for a literal square bracket, 2 literal dashes, 0 more white space, and then I don't care what is in between, just whatever it is, grab it. Could be anything. I don't really care. I just want to know what's in between this thing and this thing. So if you want to imagine something more familiar, think about angle brackets with HTML. Maybe you don't care about the angle brackets. You just want the junk in the middle, and maybe you don't even care what kind of tag it is. Whatever you just want, whatever the GUI center of that is, you want to pull it out. Well, this is one way to do it, is dot star. The question mark, what that does is it says, don't grab everything in the world, because dot star by itself is called greedy, and we'll get to these definitions in a little bit. And that means it will just keep going and going and going and going until it hits a new line or the end of the string, because those are the only 2 things it doesn't match. And usually that's not what you want. So putting the question mark after it says, hold on, don't be quite so greedy, and check and see if there's stuff over here that might match as well. Because this right here also matches this, right? Because that's not a new line, that's not a new line, not a new line, not a new line. It would, if I took this question mark out, it would match everything to the end of the string, and that's not what I want. So I put the question mark in, say, hold your horses, and let anything after this match if it can.
Well, how do you know if the capturing parentheses are going to capture the 2 spaces, or the 0 or more S's are going to capture the 2 spaces?
Well, because basically by putting this question mark on here, it will if this can match, it will match. If it doesn't match, then it'll end up inside the parentheses. In other words, it's just giving the stuff that comes after it a chance to match. Because by itself, it's greedy, and it just says, give me, give me, give me, give me, and it hits everything it can match. With the question mark on there, sometimes it's called making it lazy. So instead of being greedy, it's saying, oh yeah, whatever, character matches. But then it says, hold on, is there something after me that can match? If so, I'm going to let it match. If not, I'll grab that next character. And some of this stuff will make a whole lot more sense when we get to the end, because I've got some great tools. And that's part of, actually, I think the most important part of this talk is the debugging tools I'm going to show you at the end that allow you to actually interactively go through this stuff, which is great, because when I started with regular expressions, there really weren't maybe very few tools like that. And there are a lot of great tools out there now. So maybe hold on to that question, and we'll see if we can make some more sense of it at the end. Okay? So again, we've got 0 more white space. I think I said earlier this would grab the white space. I'm wrong. It wouldn't grab the white space. The white space would be grabbed here. So it's just going to grab tags. So I apologize for that. I think I said the wrong thing earlier. I should listen to what I say more. And then, you know, the end of this is just like the beginning of it, right? No surprises there, just little characters. Everybody fine with that so far? Okay. Okay, this is what I just promised you. These, eagerness, greed, and backtracking, oh my, these are the things that cause people the most trouble, the concepts that cause people the most trouble when they're learning regular expressions. Because it will do things that you don't necessarily expect. So, eagerness is the concept that a leftmost match wins. Quick, anybody. Does X star match the string Doug? Yes, it does. Because this is zero more. Exactly, because that I told you that zero will throw you off. You look at this, and at first glance you go, no, that's not going to match. But yes, it will match, because there are 0 X's in Doug. So yeah, it matches. So that's one of the things that's tricky you got to think about, is whenever you've got 0, a lot of times I tend to think twice. When I'm going to use star, I ask myself, do I really mean plus, where I want 1 or more, or do I really mean, 0 more? Think of the, the plus as a sniper rifle, and the star as a nuke. You might want to use the sniper rifle rather than just nuking the whole thing. That will tend to get you in trouble. Although I tend to use it probably more than a lot of people would recommend, but it's probably just because I've been doing regular expressions for a while, and I do know what it's going to do for me and against me. So, and most of the time when I use it, I put a question mark after it, because that tends to put the brakes on it. Okay, so greed was what I was talking about before. It means a quantifier will match as many times as possible. So you've got the string, the cat in the hat. So we've got an anchor. You remember, start of the string. We've got an anchor over here, end of the string. And then we've got dot star, which means 0 or more of anything that's not a new line. We've got the same thing here, and we've got the literal 2 characters act. Now this is not a character set, so the order matters here. If it was in square brackets, it could be A or T. We don't care which, and the order doesn't matter. In this case, it's parentheses, so we literally want an A followed by a T. All right? This is not going to do probably what the original writer intended for it to do. What it's going to do is, you remember, \1 is this first set of parentheses, \2 is this, \3 is this. So \1, the cat in the H. So you remember greed, I said it's just going to keep gobbling it up. It could have stopped here had I put a question mark after it, but I didn't. There's no question mark there. So it just keeps right on going. It says, screw you, everybody after this, I'm going to just grab all these characters. And that's what it does. It just keeps going and going and going until it hits the last act in the sentence. And then it says, oh, okay, I'm good. So I'm going to quit matching that. Number 2 matches the AT, and \3 matches nothing, because we've got dot star, which is 0 or more characters. That's 0 characters, so it matches. But this is probably not what the author intended. I got this example somewhere out of some documentation order, and I apologize to the author I ripped it off from, because I don't remember where I got it, but I thought it was a really good example. So, more likely what you would want to do is either put a C in here, so that it would grab everything before cat, it would grab cat in the middle, and then it would grab everything after cat. Or it would, or you would want to put a question mark after this, so to make it lazy rather than greedy. Does that make sense to everybody? Make sure. These are the very important concepts to. And even if you understand these will still trip you up from time to time. They still trip me up from time to time. throw things in there and it does something I didn't expect, then usually I look at it and I go, oh yeah, I see why I did that, and then I go back and fix it. So that's the most important part, is to be able to recognize when you've done it wrong. You look at what it did and go, oh yeah, okay, I know why you did that, and then go back and fix it. Okay, the third thing is backtracking. We haven't talked about that at all yet. For a pattern to match, the entire regular expression must match, not just part of it. So now I'm going to go ahead and show you one of these great interactive tools. So what backtracking does is, when it is going along, trying to match, it may go down a false path that looks like it's going to be successful, but then some part at the end is not going to match and it's going to fail. So when it does that, it starts backing up and trying another angle at it to see if it can make the whole thing match. So rather than any more hand waving, I'm going to actually just run this thing interactively. This is, for those in the know, this is a Damien Conway, who I think promised this at the last YAPC or something. So this is like alpha software, but so far I haven't gotten it to break. Works great. This is basically a regular expression debugger. It's got certain characters, if you used other debuggers, that you hit and it does certain things. Like the only key I'm going to worry about now is N, which just means next. So it's going to single step through matching this string with that expression. Right? So I'm just going to go through a step at a time. If anybody has any questions, stop me. And then we'll just go through. So we're starting the match, testing if at the start of the string or line, assertion satisfied. That means, yep, we're at the start. This is the pointer right here, we're at the start. So now it's saying capture the $1. Okay, I think maybe my font is too big here. Can everybody still read that? I don't want it to jump around like it was. Okay, so it's starting at the parentheses, saying it's going to try to capture. And it's trying any character except new line 0 or more times, as many as possible. So that's telling you exactly what it's doing, right? That's dot start. That's exactly what it does. 0 or more times, which we said the 0 can be surprising, and it's greedy, as many times as possible. So I hit that, and look what it does. It goes, oh yeah, great. I was able to match everything. Everything in the world. I just went to the end of the string. Wonderful. Problem is, though, this is breaking our other rule, which says the entire pattern has to match. Well, this is going to fail at the next step. This part, so far, is going, hey, everything's groovy. This is cool. I matched everything. Now we're at the end of $1, so currently we've got the whole string in there. And then we're saying capture to 2. Then we'd say trying to match a literal sequence, which is A and T. And then we go, oh darn, there's no A and T left because it gobbled everything up all the way to the end of the string. If there was an A and a T left at the end of the string, we would have been fine, but it gobbled up the entire string. There's no A and T left. So it goes, nope, that's not going to work out so well. Any questions here? That's where I'm going to stop, because this is where the backtracking starts. Is the regular expression thought everything was going along fine, cruise along, everything's great, I'm matching everything. And then it's like, hold on, wait a minute, the rest of this stuff doesn't match, so it doesn't work. So now we backtrack within the regular expression and rematch. So you notice it backed up one character, and then it's going to try again. And it's going to try to capture the 2. It's trying the literal sequence, but you notice it's matching against T. I don't know why that jumped again. And it failed again because we need A and T, not just T. That makes sense? So we failed our match again. Now we're going to backtrack again. Try again. End of $1, start of $2. trying a little sequence. Yay, we had an A and the T available. So it just backed up that pointer, and just kept trying until it finally got something that matched. So that matched. Now we're at the end of 2. And then 3, you remember this can match nothing, which is exactly what we've got left. It's nothing. And so it's trying to match any character except new line 0 more times, as many as possible. And it says, yep, I got nothing. And this matches nothing. End of 3, testing if we're at the end of the string. Remember, because of our anchors, it says, yep, we're at the end of the string, so we're cool. And we're done. We matched in 27 steps. Now, 27 steps may seem like a lot. The regular expressions are, at least if the engine is implemented right, and in Perl, I would say it is, blazingly fast. They're incredibly fast. Even if you're doing a lot more backtracking than this, I've written some parsing code that ends up. I didn't realize how much backtracking it did until I ran it through this, and I went, wow, that really does a lot of backtracking, but it's still incredibly fast. Okay, and we're at the end. Does that make more sense now, what backtracking is? This is what I love about this tool, is being able to actually step through it step by step and go, oh, this is a wonderful way to debug. If you've got a regular expression and you have a string and you don't know why it's not matching the way you intend, just step through it. And this will show you exactly at what point it goes awry. And then hopefully that will tell you, oh, I need to change this or put a question mark on it or whatever. Right? We need more questions.
Do you put the string match and the regular expression inside the code, the backtracking PL?
Yeah, I can show you that. It's very simple. I don't know if you can see that though. Okay. Most of it is use strict, use warnings, and basically all it does is I'm using, ahead of this, there's a command line program that comes with the module called RX. So you just say RX program, and then it will just go through your regular expressions and step through them. And I've actually used it to step through multiple regular expressions in the same program and had it work. I don't know if it succeeds all the time or not. Like I said, this is pretty alpha, but it's pretty amazing. It just pretty much does any regular expression that's in the same scope as whatever it's running, it will run through the debugger for you. So, in fact, I'm going to leave this up in case there are any of the other examples you guys want me to step through at the end. I'll just modify this and we'll step through it.
Can you put a question mark after the first step?
Oh, yeah, actually that's great because yes, actually as I was doing this presentation, I did that myself. We'll run through it. Right. Okay, now we've got the question mark. Remember how I was claiming earlier? Well, now we'll find out whether or not I have egg on my face. This is always fun. Now I'm flying without a wire here. Okay, whoops, okay, we're trying to match anything possible, matched, end of 1. Now you noticed, instead of, by now, it had already grabbed the whole string the last time. Now it's stopping because of this question mark and it's going, oh, let me be polite and let me see if anything else after this matches. Rather than me being greedy and gobbling everything up, I'll be lazy. And well, so far it's matching the T, but then it's going to say, let me see what the rest of you can do.
And it says $1 is an empty string.
Okay, yeah, that's true. Actually, because it doesn't match the T until it sees if the rest of it matches. Good point. Okay, so trying the literal sequence, we don't have at there, so it's going to backtrack.
It matched the zero first. The 0 more characters.
That's true. Thank you.
That's what it matched first.
Yes, it matched the nothingness in front of the T is what it matched first.
And now it's gonna front track instead of back track.
So it's going to try to, and I'm just gonna kind of bounce on this, because this is gonna do a lot more backtracking, as you might imagine, until we get to something a little interesting, and then I'll slow down. Failed. Failed. Okay, now we're not gonna fail, so there it matched. And so now, you see, instead of backtracking, we're actually going forward now, because that part matched, so it's gonna keep trying the rest of it. And now it gets to be greedy. It says, woohoo, I grab everything to the end. Matched, end of 3, testing it from the end, we are, boom, done. 42 steps, so you notice it did backtrack more that time. But now you can literally see what that question mark does for you. It stops this from being greedy and lets this other stuff have a turn, rather than being the kid that grabs all the candy and doesn't let any of the other kids that are coming after it grab any. It just grabs one piece of candy and then says, hey, you guys match any of this candy? You like any of this stuff? Lets them have their chance. And if they can, then great. If they can't, then it grabs another piece and then lets them try again. So that's what the backtracking is all about. It just keeps going back, keeps trying and trying and trying. And in our case, all of my examples succeeded. You actually have matches that will fail. If we put like another character in there, it won't match at all. If we put like an ATX in there, it won't match. In fact, if you want to,
How would you modify the string there to get it to match on all occurrences of AT?
oh, all occurrences of AT, well, first of all, I would lose the anchors, I would lose this and that part. I would lose this anchor, and then I would put a G at the end for global. And then that way, it would go through repeatedly and just find every single A followed by a T that it can find. If I don't care about case, I'd also put an I on there, so you could have a G, I, and it would be case insensitive. So it would grab the word at, like at the beginning of a sentence or something. Like it
So
was
how
capitalized.
many dollars would you get then? Would it be 4? How many capture pieces would you
It depends on how many ats there are. If you had 100 ats in there, you would have 100 variables.
Right, but is it still gonna, there would be 4 instead of 3, right? If you wanted to match the at.
There should only be 2.
No, there's only
two ats.
2 in this example because we've got one at there, we've got one
No,
at
I know,
there.
but you still have $1 plus C, and then you still have, you have in the H, right?
Well,
You're talking about if you leave this part.
Yeah.
Yeah, that's
if you just
different,
take off
yes.
the
You
dollar
leave-
and put the G. Match all the ats plus the regular expression variable.
I still think that's probably not gonna work how you think because this one is still greedy. I'd have to run through it to be sure, and that's, a perfect example of, I don't really know what it's gonna do. I'd have to try it and see. But I'm not positive that it's gonna end up doing what you want because this thing is greedy. It might still work out okay. But we'll see. I wanna still go through a couple more slides and then actually we're a little over time, but we'll maybe come back and run some more examples at the end. Okay. These are some of the debugging tools that I was talking about. This is a Perl module that explains in words, but it doesn't do the interactive thing. It just goes through and breaks it out for you and explains in words what a regular expression does. I've got an example that I'll show you. Padre is a Perl editor, which has a built-in regular expression tool, which is really nice. It allows you to put in regular expression, put in text, put in replacement text if you're doing search and replaces, and it tells you whether it matches or doesn't match, and it does the replacements for you. So runs on Windows and Linux. I don't know if it runs on Mac or not. I know it at least runs on Windows and Linux. This is what we were just looking at. This is the name of the module. The executable is just RX. And then this is a website, which I will show you, which allows you to just go in and type regular expressions and strings in and play around with them as well. So let's go to the explanation. This is just explaining. And this is, you remember this regular expression from before, right? This is the same thing I was using before to match the tag. This is an alternative way of specifying the flags at the end, like the I for case insensitive or the G for global. You can also put them in parentheses, question mark, and then put the flags here. That's just an alternative way of doing it. And that just happens to be the way that this does it. Because when it's in a string, it's got to be inside the regular expression, and flags are outside the regular expression, right? Because they're after the closing slash. So that's why this uses this way of doing it. This is just a default. This is the default way things are going to match. Group but don't capture with these two anchors matching normally, with dot not matching, \n, which you remember that, I told you that was the default. And it matches white space and the comment character normally, because that minus in there says none of these are in effect. So we're not, it's like not I, not M, not S, not X. And that's just explaining to you what the defaults are. If you don't specify any flags, that's what it looks like. So then it's looking at, oh, these are just more flags. Again, this is just kind of repeating this information. Then this is the regular expression part. You notice backslash square bracket is a literal square bracket. Then we've got our two dashes, literal. Then we've got white space, and then it lists out, you remember, just like I did in my earlier slide, exactly what white space means, 0 or more time, matching the most amount possible. So a lot of this, the wording is a little different, but you can see it's similar to the explanations that we saw in the interactive. But this is just nice if, let's say you have somebody else's regular expression that works fine, it's not buggy, so you don't necessarily need to step through it. But you can run it through this real quick, just to see, well, what's it doing. And this just breaks it out for you step by step, what every single piece of it is doing. And again, this is a beautiful tool. Didn't used to have nice tools like this that would explain it to you in plain English what the heck it's doing. So, thought I would show you that example. Now the Debug X. This is the website, and I just put this in because we're familiar with the example already. So this is the same regular expression we've seen. This is the same tag down here. You notice the green tells me it matches. This right here just tells me the flow of how the regular expression goes through. And I just wanted to show you. See, I can sit here and put as much space or take out any of the space, and it's still going to match. But if I get rid of one of those dashes, all bets are off, because up here we specified we need 2 of them, right? We're up. So if I delete one of those, it doesn't match anymore. I could also sit in here and type this is a tag. And again, since this is just grabbing whatever's in the middle and you don't happen to care what it is, you notice $1, this is a tag. It's just grabbing all of that. This is grabbing this white space. This is grabbing this white space. And, you know, the literals we already talked about that. That makes sense? Again, another great tool to sit here and just play around with it, see what happens. That's really the best way to learn regular expressions. In fact, I made the joke earlier today, mash on the punctuation keys until it works. So that's the old way of debugging. The new way is you've got all these nice tools, and there are actually several other websites that did similar things. This one just happened to kind of jump out at me the most out of those two. Part of it is because too, you were able to specify JavaScript, Python. PCRE is Perl compatible regular expressions. So that's Perl and any other language that has Perl compatible regular expressions, which are a lot. I think .NET uses them, doesn't it? Java does, I think. So a lot of other languages use the same syntax. So you can use that there. All right. Last but not least, these are the references. I'm not going to link out to these, but this is an O'Reilly book, and these two are documentation that come with Perl. And it's just Perl regular expression tutorial and Perl regular expressions, just the documentation. So I stole a lot of examples and information from those just to list those out. Any questions? Everybody feel like they're doing okay?
Yeah, I got a question.
Sure.
Earlier in the talk, you said you could have a regular expression that captures all the words in a paragraph or a page and counts them up. Does the regular expression do the counting and summation, or is that logic?
No, you would need logic. Yes, and that's a good example of a useful use of a regular expression. What you do too, this kind of goes back to your earlier question where I didn't quite understand what you were asking, and I said you may have 100 of them. Well, that's a case where you may have 100 words in the paragraph. You can, instead of doing the $1, $2, blah, 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 you can instead stick those in an array, right? And then you don't care how many there are. And then you can have Perl just tell you how many things are in this array. And then boom, you've got your answer. And just,
How do you do that?
like 5 lines of code.
How do you do that in an array instead of a single dollar?
Basically, you put an array on the other end of the slide. Now we're kind of getting into stuff I'm kind of going to beg off because that's going to be in my next talk because those are a little more advanced concept. Yeah. So, either that or I have no idea how to do it and I'm just making stuff up and I don't want to talk about it until I figure it out. Now, really, I did want to talk about all that stuff, but we're actually already 10 minutes over, so I think we'll go ahead and call it unless anybody has any other questions.
Do you have this online?
It will be online as soon as we get the video done. It'll be on YouTube.
Besides the video, is that on a website or a
It will be. Basically, once we put the video up, we put the link under the video on YouTube, so we've got both at the same time. So yes, it will be.
I talked on.
Thank you all for coming.
Thank you.